Now that we have known slope and intercept, how do they combine to get us an equation that governs a physical system? Don't forget that both the slope and intercept are gotten especially from straight line plots or sketches. Again, I ask, how do we use slope and intercept to create an equation that governs a physical system? That takes us to lesson number 7, and that is using intercept and slope to generate equation that governs a physical system. Please listen as I develop this section. To derive an equation from a Cartesian straight line, there are 2 things we have to do. These 2 things are based on observations. In a moment, you get to understand what I mean. What are these 2 things we have to do? To get an equation out of a Cartesian straight line, I emphasize the expression straight line because not all Cartesian plots or sketches are straight. But to get an equation out of Cartesian straight line, we have to obtain the slope of that straight line and the intercept of that straight line. Let us use our foregoing Cartesian sketch to demonstrate an example. That same sketch we have been using for quite a while now. Now, recall that we got the slope of this sketch and we also got its intercept. We got one slope and we got 2 intercepts. What are we going to do with these 2 things after we get them? Before I tell you, look at this equation. Y is equal to 2x plus 5. This is the equation we got earlier from this table. That is, after trial and error, after using hypothetical process, we got this formula for equation connecting y and x, which is y is equal to 2x plus 5. I know you recall. I know you remember. That is the same thing lifted and written here. Y is equal to 2x plus 5 explains or illustrates this straight line. Now, we have found the slope and intercept of that same sketch. Let us recall what the slope and intercepts are. We recall that the slope we got was equal to 2. Symbolically, m is equal to 2 because m is a symbol of slope. Also, vertical intercept, we got it to be equal to 5. We therefore say that c is equal to 5. C here represents the vertical intercept. We also recall that horizontal intercept was gotten to be minus 2.4. These things were gotten from this Cartesian sketch. Now, let's compare these values we got, especially the slope and vertical intercept, with the equation we had gotten earlier from the table. From the table, we got y is equal to 2x plus 5. And now, from the sketch, we got that slope is 2 and vertical intercept is 5. Could it be that this 2 is this and this 5 is this? If it is, let us try writing a formula for a straight line, and later we use other examples to confirm that that formula is correct. Let us see. See a proposed equation of a straight line. That it is going to be correct depends on what we see later. If this equation is not consistent with cases we're going to see afterwards, then the equation will be regarded as defective. But if it remains consistent, this is equation of a straight line on any Cartesian space. See this y, the same y here, equal to, the same equal to. This 2 is the slope only for this table. But for any table at all, we use m. Therefore, we replace this 2 with m, because earlier we said that 2, which is the slope, is equal to m. M is a symbol. 2 is a value for this special case here. We cannot conclude that every slope everywhere is 2. Slope is 2 only for this case. Therefore, we have y is equal to mx, that is slope times the independent variable. We have plus here only because this y leads. Y is leading because all of these are for y. And y leads by 5. So to lead is this plus. Can y lag? Yes. Sometimes y can lag. If line of best fit crosses like this, you will see in that case that y lags while x leads. Until then, just know it that it is possible for y to lead or lag. In this particular case, it is leading by 5, but it can also lag. What it means is that what could be here is either plus or minus. That is why this expression, this symbol came here. Therefore, y is equal to mx plus or minus c. This 5 is the c. Don't forget that c is equal to 5. C is symbol for all intercepts, all vertical intercepts. But for this case at hand, the c is equal to 5. So we replace this 5 with the c. That is how this c came to be. Therefore, the equation of a straight line on any Cartesian space is given as y is equal to mx plus or minus c, where m stands for the slope and c stands for the intercept. Don't forget that this is subject to verification, but we're almost sure that this is not going to be a coincidence. Let us try and see whether this formula is correct or not. But don't forget how we arrived at this. We did so by comparing the slope and intercept which we got from this plot with the equation we have gotten before. After doing so, this is what we saw. And right now, let's try and see whether we can either validate or correct this equation of a straight line. Let us see. Now let's consider the second example on how to derive an equation from Cartesian straight line. Let us use this instance for this purpose. We recall that it is from this table that we got what we wanted to have this Cartesian sketch, which you are seeing on the screen. And recall also that we got this equation by hypothesis from this table. Y is equal to 5x minus 2. Don't forget that this was not gotten from this Cartesian sketch. This was gotten from this table. This was possible only because of some consistencies observed in this table. Does it mean that if we fail to observe consistencies in tables, that table can no longer lead to an equation? No. Every table can lead to an equation as long as that table contains values obtained from real-life situations via experimentation. Again, equation for this table is y is equal to 5x minus 2. Assuming that this table is not easy enough to be handled this way, and we resort to use of Cartesian sketch like this, how do we use this sketch to find this equation? Now, let us turn our attention to using this sketch to find this equation. Afterwards, we know whether what we find from this sketch is equal to what we found from the table by means of hypothesis. Let's recall, what is the step, or what are the steps of deriving an equation from a straight line plot on a Cartesian space? The first step is to find the slope using the line of best fit of that plot. At this point, we have found the slope to be equal to 5. The second step is that we have to find the vertical intercept, not both intercepts. In this case, only one of them is needed for that equation. That is, if y remains the dependent variable, it is y that is forming the subject of the equation we'll be deriving. That means that whatever we see on the right-hand side of an expression after y is a formula for finding y. Therefore, the next thing we do is to find the vertical intercept, that is the y-intercept. Now, with respect to this Cartesian sketch, having found that the slope is equal to 5, we have also found that the vertical intercept is -2. Now we have found the slope and the intercept. What are we doing with them? We go back to our former proposition. What is it? Let's recall. We recall that we proposed earlier that y is equal to mx plus or minus c, where m refers to the slope, x refers to the independent variable, c refers to the vertical intercept, while y refers to dependent variable. With our former example, this is what we got as a proposition, and with this example right now, we are trying to find out if we have to validate this proposition and make it a formula. How? If m, which is the slope, corresponds to what we found right now as the slope, and c, which is the vertical intercept, corresponds to what we just found now as the intercept for the vertical axis, it means that this formula is valid, especially because we're going to compare that with this equation. Don't forget that this y is equal to 5x minus 2 is the equation for this table. And this table gave us this Cartesian sketch. Does it mean that each time we have to derive an equation from a table or for a table that we must use the trial and error method? No. From this Cartesian sketch, we can also get an equation. How? Look at this again. Y is still here. It is here. This is equal to, it is still there. 5 is what we got from here. Then, and this 5 corresponds to what m is supposed to be here. M is the slope. Don't forget that m is symbol of slope. And notice that this m from this sketch is equal to 5. What it means is that this 5 we found from trial and error method corresponds to the 5 we found from calculations in the Cartesian sketch. Could that also be a coincidence? Earlier, we were asking whether this was a coincidence. This is more than a coincidence. The first time, the slope we got from the sketch matched the coefficient of the x, which we got from the table. And now the same thing is playing out. This may not be a coincidence. If we try this kind of thing again and again, we see that this is going to be true. Okay, let's conclude by looking at this minus 2. This minus 2 corresponds to this c here. Okay, 2 corresponds to it. In this case, it is minus. We don't know what it is going to be minus here in the case of this plot here. This c refers to vertical intercept, otherwise known as the y-intercept. With respect to this Cartesian plane, having gotten its intercept, its y-intercept as minus 2, if we compare this minus 2 with this minus 2 here, and at last compare it with this c, what it means is that from the table, the constant we got after 5x is minus 2. From the sketch, we still got the same minus 2 as the intercept, the y-intercept. Therefore, what is here is this minus 2, which means the slope from this sketch became 5, and its intercept still became minus 2. Therefore, this is more than a coincidence. We have observed something which appears to be consistent. Because of this, we can conclude that the equation of a straight line is given by y is equal to mx plus c. Therefore, y is equal to 5x minus 2 is the formula for this table, both by hypothesis and by Cartesian sketch. Sketch the following tables on Cartesian plane, and hence obtain the equations governing the tables using y is equal to mx plus or minus c. Please, before you make use of this equation, be sure that you have found the slope and the vertical intercept after getting the Cartesian sketches of these three tables. Table number 1, number 2, number 3. Please, do well to compare your results with results of others. And now, checkpoint. It says, predict the slope and vertical intercept of Cartesian sketches for the following linear equations. I believe you know what this is all about. I mean, did you understand the instruction? In case you did not, what it means is that you should foretell or tell ahead of time what will be the slope and intercept of each of these equations if each of them is shown on Cartesian sketch. That is, if we sketch this on Cartesian space, what is going to be the slope from that sketch and what will be the vertical intercept from that sketch? The same thing applicable to others. I believe that you have heard things that will help you remember how to go about this, especially in connection with our equation of a straight line, that is y is equal to mx plus or minus c.